All right, we're moving on to our next session, knowledge graphs to power financial chatbots. Please don't hesitate to ask questions using the questions tab on your screen. We'll have a brief Q&A session at the end of the presentation, and if we don't get to your questions, someone from Neo4j will be in touch with you. Lance, I'll go ahead and turn it over to you.
Mayank Gupta is Senior Vice President of Data for LPL Financial. Mayank has many years of experience as a product manager and a data lead for companies like Bloomberg, UBS, and Morgan Stanley. He's got a degree in mathematics and computer science from Rutgers. Wren is a Vice President of Foundational Architecture and Innovation at LPL. Prior to LPL, Wren spent 7 years as an associate director and a senior software engineer at UBS. Wren has an amazing background. He's got a master's in material science and engineering from Carnegie Mellon and a master's in cybersecurity from New York University Polytechnic School of Engineering. For this next session, we have a lot of customers who use knowledge graphs behind interactive chatbots, incorporating natural processing techniques and in many cases, artificial intelligence. So let's hear more about it from the LPL team. Welcome, Mayank. Welcome, Wren.
Hello, everyone. Thank you, Lance, for the introduction. So, folks, I am Mayank Gupta. I lead the Enterprise Data and Information Services Department at LPL Financial. And today, what we wanted to present to you was essentially on how we are building a knowledge graph and the use cases that we are applying it to. The technologies that we are going to be presenting that are in play today are Neo4j, GraphAware's Hume, Elasticsearch, and a variety of stacks, components on AWS, primarily Lex. So essentially to talk about LPL's graph mechanisms and journeys, we've presented this late last year to the Neo4j community. We've been users of graph since 2017 and been applying it to several business use cases. As a part of that, we've run into a concept, or we've sort of self-created a concept of a metagraph to help our current software engineers, modelers, developers, technology folks, and our business folks conceptualize and be able to leverage graphs better. And so this is this concept of a metagraph. What I'm showing on the screen is our enterprise architecture data model rendered out as a graph. And what you can see is the concepts that people are used to that they can share. And instance data would essentially be an is-a relationship against this. What this has allowed us to do and sort of market across the company with our business users is the power of knowledge graphs and the experiment that we have done to show how we can build and apply knowledge graphs to really help LPL. Presenting this capability, building this capability, which essentially was done as a side of the desk activity, so not a formal project, but the tooling that we've been using, the graph concepts, Hume's software, Neo4j's graph database, have really enabled us to do this very rapidly and make tremendous progress. The fellow presenting this is Wren. He's our Vice President of Foundational Architecture and Innovation. And over to you, Wren, to talk about our use cases.
All right. So some of you might be familiar with Maslow's hierarchy of human needs. So the pyramid on the left is from Uber's version that they presented in last year's Knowledge Graph conference in New York that outlines the hierarchy of drivers for enterprise knowledge graph. Right now, LPL is still in the early stages of using graph technology, but we already are seeing the power of and as well as the potential for knowledge graph within the firm. So what we have below is a meta model that defines and explains a knowledge graph in the form of a graph. On the meta model, you can see that the use cases that Neo4j enables is a little out of date because of recent updates to the graph data science capabilities. There are some features that could have been used for the pilot, but it wasn't available at the time.
Yeah, and regardless, with the tooling, with the capabilities from GraphAware and Neo4j, we have essentially made the building of our knowledge graph far more automated, far more better, and we really focused on search and sort of expressions as our key use cases. The two main visible applications that we will put forth are essentially much improved search, which can be maintained and scaled, and a far better chatbot that Wren has built that can also be maintained and scaled appropriately.
So the knowledge graph for this pilot, we're thinking about using it effectively to have a single source of truth. All our knowledge would be represented in this knowledge graph, and we want to be able to enable multiple business application, business use cases such as chatbot and search, like Mayank mentioned. The challenge, the holy grail, really is we want to master that knowledge in one place and then propagate that single source of truth onto these omni-channel experiences. So this slide covers effectively 4 generic, I guess, benefits of a knowledge graph that it is able to capture complex relationships easily. The example of what we think of a knowledge graph kind of enables is effectively, if you're a Star Trek fan, Vulcan mind meld. We're able to capture and able to share context holistically and precisely with each other. That is the end goal of being able to enable a knowledge graph, being able to take information that everyone's been, knowledge that everyone has in their head, and be able to represent it in a way that's beneficial to the firm. We want to be able to create this single brain for the organization. The EDM Council has presented in a recent webinar 4 reasons for the use of knowledge graph from a data perspective. Those 4 reasons are common semantic language, being able to describe meaning of concepts for human and machines alike, smart data quality rules, ability to define reusable standards that are executable, data asset knowledge, we're able to layer our physical data assets to understand the underlying concepts. This is pretty much the data governance. How do you tie what we store in our data stores to the actual concepts? Holistic linked data. We want to be able to have a harmonized view of the data. This is where JSON LD, for example, would be applied. We're able to link our data and reference it across the enterprise. So over here, you're seeing the meta graph that we have for the pilot that we've put together. At the core, near the left, actually near the center, would be the document that we've loaded into the knowledge graph. What we were trying to do is that LPL has these documents, resource-centered documents that represent the knowledge base. And it's used by our advisors and to be able to figure out their how-to guides, and they help our advisor do their work. We want to be able to capture and take that knowledge that is in these documents and be able to start extracting the core concepts out of it, start using these core concepts to then enable the rich omni-channel experience that was mentioned earlier. And we start enriching, adding other elements that are related to it. So this is the final version of what we put together. So right here, we'll be the next couple of slides. We'll be showing some slides that we got from Graphware for how the ingestion process works for Hume to kind of go over what was done in order to get the data to that shape that was mentioned before. In the first step, we ingest the data, the documents, and this enables the second step, which would be applying NLP against the data. For this particular pilot, we use a really basic NLP algorithm that extracted the 25 keywords out of the documents. The next step, which is more important, is being able to tie the keywords that were extracted from these documents to other data sources. For example, we were able to tie it to a generic concept knowledge graph that we got from conceptnet.io. We're able to tie it to the Investopedia financial terms glossary. We're able to tie it to an internal dictionary for LPL. we added some data from call center analytics, where they performed some manual tagging of these articles to questions that our advisors would ask. They also added they gave us some metrics such as what do you call it? They associated the search terms that they would use to the articles themselves. So we have, it's effectively, we got some early feedback information that we tied to these core documents. We were never able to do carry out the machine learning phase, but if we were able to get some help from the business side, we would able to add more. We would be able to extract more tags that would have we couldn't have seen otherwise. So to recap, this slide deck kind of goes over kind of our high level understanding of what the human enables. You can kind of see as the center as the brain, where the brain keeps creating and updating connections. It keeps learning. You have inputs on the sides. You have feedback mechanism. You have motor functions that a brain enables, right? That's our business applications, right? The business use case, chat, search, they're all motor functions that this brain enables.
So, and just to interject in, this is actually an incredibly important and powerful point of using and applying knowledge graphs at scale. It's possible for certain areas and departments to get together and sort of do this by hand, right? And unless you're using an actual physical graph underneath the covers, which is, to Wren's point, a single source of truth for the organization, unless you have really rich intuitive interfaces to allow the feedback loops from both humans, machines, usage to come in, you're going to struggle to apply knowledge graphs well and at scale. And I think it's important to point out that the combination of Neo4j's graph database, its capabilities, and the Hume algorithms, the Hume software and process, are really what make this easy to do, but also make it relevant, because you have to make knowledge changes, right? That's one of the changes is really the heart of changes, that we learn more and more, that we see more and more, and that's true for humans as well as it is for organizations. And to make knowledge graphs effective, this model actually is something that can keep up at the pace of the organization. So now we're going to flip into use cases that Wren's going to review with you guys, both what it was and how it was put together. Over to you, Wren.
Yeah. So we were able to optimize search with the tagging that was extracted through the use of the knowledge graph, and the tagging is effectively just running graph analytics against the knowledge graph and being able to find out and put a weight on some of these tags that we can find against a document. It's pretty straightforward. The search application that was implemented was a simple front end over Elasticsearch engine. The documents are again loaded into this Elasticsearch engine with the tags derived. Note that we haven't had the time to tune the search weights, but out of the box, just weighing everything equal, the title, the tags that we extracted, we're actually seeing a average of 67% search relevancy for this search application versus the average of 57% search relevancy for the current state, which they're still carrying out a manual tagging effort, and we believe that it is going to take more time to do it. So like out of the box, the capability to be able to automatically extract these tags out of the documents themselves, and it's pretty powerful. We able to get improve search relevancy without that much tuning, and we believe we can add feedback mechanism, number of clicks, for example, maybe allow people to be able to vote like whether a tag is relevant. That would help us to be able to crowdsource that tagging as well.
Yep. And I mean, I think I would add that if you actually had the same people at the org who are building those manual tags today into the process, and as you get those signals and feedback, what you're doing is you're probably going to hit 80-90% relevancy, right? And that's like 9 out of 10 times when the user asks the question, or 95 out of 100 times when they ask the questions, they get to the most relevant content. The amount of savings and time and effort that can deliver for our home office users, for our customers is incredible. So take this as a very initial, to Wren's point, out of the box, which is already beating the manual tagging that we're doing, and the potential here to modify our process to involve those same taggers, as it were, to making the knowledge graph better is, we believe, is profound. And we will come back to you guys with that in a future update. But we're very excited about this application that we actually got better just out of the box with this setup.
Yes, and one of the phases that I mentioned before, the machine learning phase, it was mentioned that we can feedback from our knowledge workers back into this into the NLP algorithms. Right now, I think the NLP phase that we use to be able to extract the keywords was actually based on the default trained model that was provided to us by GraphAware. It's not trained to be able to handle financial terms, for example. We can actually take that feedback and make it better. We can extract the more relevant tags. Maybe there was a tag that was skipped over because the model didn't know it was important to us.
Yep. And then using the same graph, Wren's going to talk about use case number 2, which was chatbot. Important point to remember, this is the same graph that is driving both applications.
Oh, the use case number 2 is actually the related documents. It's a minor use case because what we're trying to do was be able to find duplicate documents and remove them, because as part of how the knowledge creation transfer process is really complex, and sometimes people create these zombie documents that exist and no one has the guts to delete it because they don't know whether it's relevant. So one of the things is being able to cluster these related documents and how are they similar. This is the use case I mentioned before where similarity would have been useful, being able to figure out these documents are really, really similar based on the concepts that are represented underneath the cover. We can then get our omni-channel team and knowledge knowledge workers to be able to look at these documents and clean them up, be able to merge them into one updated copy. So we were able to really quickly prove that we can cluster these documents, closely related documents, based on keyword co-occurrence. And then from there, we were able to take the next step, which is, all right, out of these related documents, here are the really important keywords. Now, give us a rank of which ones rank high based on these keywords. And this use case is still a work in progress, which is why it isn't mentioned as prominently. The more important use case is really the chatbot and search, but this is one of the asks from our omni-channel team.
Yep.
So moving on to the next important use case, which Mike teed up before, the chatbot. Right here, you're really seeing the flow that is being captured, that kind of tells that directs a conversation between an advisor and the LPL chatbot. In this example, the diamonds are questions that the chatbot would ask. The ovals are potential answers that user would give, and the squares are the responses that the chatbot would give at the very end. So we were able to capture the flows that are seen in the red and blue boxes. We reproduced this model completely in Lex, Amazon Lex. Right now, the issue with this model is that it's really static. It's hard to share, and if changes are needed, it's really difficult to do right because you don't. If you want to add additional response, you have to figure out where you might have potentially missed a flow. So what you're seeing here is pretty much a more dynamic model that we created. If you think about it, it's really we applied effectively a graph transformation from what was seen previously into this model. And I believe there are graph transformation algorithms that exist, but I haven't seen any good examples of it being implemented yet. So that's probably a wish list if Neo4j can work on it. In this model, you can see that it better captures the relationship between the question, which is in yellow and called intent in Lex, the clarifying queries in green and pink, they're called slots in Lex, to the response in blue. And you can see that the response pretty much could correspond roughly to the resource center documents that we mentioned for the search use case, and the rest of the nodes that are connected to her, you can probably derive some tags that can actually help us improve search from the first use case. This model that we're using here actually allows us to be able to dynamically figure out how many more questions we have to ask to figure out what the user is trying to arrive at, and also narrow down what options are available. It figures out based on the responses that are left what options are available that are applicable. So there are some options that kind of get eliminated by process of elimination. We don't even ask that as part of the chatbot. So this is what this use case enables.
Yeah, and I mean, I think one of the key takeaways is the more knowledge graphs get used, the more cases that they get applied to, the more powerful, the more useful, the smarter the knowledge graph gets, right? Baby Yoda grows up to be whatever Baby Yoda is supposed to be. I'm very keenly looking forward to continuing his journey or following his journey. But it is in our little bit of investment and time, and Wren's deeply become an expert in this because of his passion and keeps me informed. We think there's incredible potential here, and I think this is going to change significantly our clients' experiences, and I think our organization's experience and ability to deliver information to the company and all of our users. We don't say the term Vulcan mind meld lightly, because ultimately all of this usage and all of this buildup, it will enable much smoother communication, even amongst ourselves. And that's, I think, our ultimate objective is in terms of increasing our agility to bring current and new folks onto the platform, into our ecosystem, for them to be able to query this and share this. We're not far away from asking the computer, a Siri, or asking the computer complex questions, and it being able to answer instead, without having us sit there and statically program those answers in. We'll open up to any questions folks might have, but we're very excited with this approach and the enablement that Neo4j has done within this work.
To add to Mike's point about being able to enable that kind of more open chat, I think there's some good news in the open source community. Facebook open source their what they call BlenderBot, and I believe Google's in the process of open sourcing something called Mina. They're both supposed to be AI chatbots that you're supposed to train data, and it'll be able to chat with someone in a way that sounds human. We don't really have any idea what that training process is, but hopefully it would involve some integration with a graph, so we can take that data that we're capturing and kind of reuse it to have a experience that's really Watson-like without the supercomputer, of course.
Yeah.
Very cool. Thank you all so much. So we have a couple of questions. So did you guys start with a set ontology, or did you build your own ontology or any sort of?
So we took in a variety of ontologies, and our intent is to over time derive it, right? So instead of sort of saying, look, we have to know everything, to a large extent, we went to open sources, right? So Investopedia offers a dictionary of keywords and definitions that we utilized a lot. conceptio.net was very useful in sort of acting as a glue between various nodes. But we did have something from an LPL perspective. There was a little bit of work for us to map this, and I think that there is a longer term work to map it, but it's not necessary for us to actually construct an ontology, more so to map it, to extract it and enable mapping between various ontologies to get to it. So sorry for the long answer, but yeah, we didn't spend a lot of time constructing it, or we did not have a good enough thing, but using this stack and this process, we wound up with a better ontology. I'm hoping that answered your question.
Mm-hmm.
I think I could probably add to as well. Sure. What Mike was mentioning, because like Mike said, we have a rough idea. We actually start creating links between what the generic concept graph, the keywords are extracted, connected to the LPL keywords, connected to the Investopedia financial terms dictionary. But there are some gaps along the way. I think we use really strict equals, like some of these terms have to be exactly equal, right? We could have used a more coarser, like how similar they are based on the Leverstein distance, right?
Yeah,
we could have done that, like fuzzier. We could have done a lot of that, but like what happened was we wanted to be able to get that search capability out, and there are a lot of some tuning that we could have done, right, to be able to enforce some of the connections. For example, there are some words in English that mean multiple stuff, right? We seen it as an example. I think when we were doing the search, there was a keyword that was so generic that it could apply for something else. So like we could have gotten rid of that. We can made it so that we can work with our partners to figure out, like, can you for this keyword, I need some additional context to figure out whether it's applicable for the financial industry instead of like wherever the original generic use case is. We could have done that. And like the enterprise architecture graph that you actually seen was actually, as I start to load the data in, I pulled effectively use sysadmin commands to be able to populate it. As I pulled the data in, some of these relationships didn't make sense. It was pretty easy using Cypher queries to actually recreate these relationships. So I think it's an iterative process. Sometimes some of these relationships don't make sense. You destroy the relationship and recreate them. That's the power of the graph. And what we did, even the graph, that meta graph that we showed for the pilot, with the help of the vendor Graphware, we were able to recreate some of these relationships if they didn't make sense. We destroyed these, we added weights to these tags as we go through it to make sure it's correct as much as we can.
Yep. Yeah. So you don't have to start with a perfect ontology. In fact, I think this helps you improve whether you have an ontology or not. It will either create one for you or help you create one, or it will improve it.
Yes. Yeah.
Very cool. Okay. Another question, so I think you mentioned that you allow users to add tags and such, or maybe you're building that in. How do you maintain data governance on that, or ensure some level of data governance? So
at the moment, we did not in the POC. And so you're quite right. That is an important thing. LPL has a knowledge management, a set of knowledge workers that do this today, right? And our biggest, my opinion, right? And I'm sure Wren will have others as well, or hopefully he'll agree. But our biggest challenge in this was how to bring forth the creation, the management, the update of the graph to our business users, right? What we would imagine is, as we create that perspective across this system, this flow, this process, we would then sort of start to say, look, we have gone through our material, we have proposed what it would be as initial definitions. Let's refine them, apply them to the graph, and to what Wren was mentioning with the ontology question, start to iterate over it. Then we can use a variety of tools, the data governance tools, to say, look, here's a concept, right? It's essentially a logical concept. Here's a generic or even a fuzzy definition for it that we maintain, and that concept can then become the area where we govern those tags and and those definitions, and essentially reapply them in a feedback loop to the graph itself. But that was not something that we did. But we recognized that having created them, it was a need, and both the sort of an interface, a process, a mechanism to extract that out, to integrate it with a governance tool like Calibra or Informatica's Enterprise Data Catalog, Stroke Axon. There's a variety of such tools out there that we could have integrated with. But it didn't detract us from actually creating the tags, right? Because we think that there's what you believe, and then there's what's reality or what comes out from the content and the data that you have. And really what this does is enables marrying the two. And yeah, again, to reiterate, we probably need a UI on top of it that enables business users to engage with it without necessarily having to learn Cypher and so forth.
Mm-hmm.
Yeah, and I think to add to what Mike mentioned, right? Just because this is one of the features that are in the recent Neo4j, which is I believe you're probably one of the first ones that actually added a pretty fine-grained access control on nodes and relationships. What happened is in the federated knowledge graph, these tagging that you mentioned could be effectively owned. We can make it so that the access to be able to write, delete, and et cetera is owned by a team that's responsible, will create the UI to be able to manage it. Like, so they're the only ones that can tamper with that.
Very cool. I think that's all the time that we have. So Marilee, I'll turn it back over to you.
Great. Thanks so much. Thanks, Mayank. Thanks, Wren, for a great presentation. It was really interesting to see the work that's being done on this front. And Greta, thank you so much for moderating Q&A. And for our audience members, I just want you to know our next presentation is coming up shortly, so stay tuned. And I think that's it for now. So if your question wasn't answered in this session, someone from the Neo4j team will reach out to you directly and answer that for you. And stay tuned for our next session. Thanks so much.